Next instruction, what we are going to see was move direct comma direct. In this case, source is also a direct address, destination is also a direct address. That means a data from direct byte memory location will be transferred to another direct byte memory location. Simple example, suppose move 65 comma 55. In this case, both source and destination will be acting as a direct memory addresses. So data from 55 memory location will be stored to memory location 65. So simple example is, if suppose 55 is having a data of 0A and 65 is having a data of 23. What happens here? After executing the instruction, a data of 55 memory location will be loaded to 65 memory location. That means the data from here will be stored here. So this is what happens. So 55 will be having 0A and also 65 will be having 0A. So this is what happens with this instruction. Next, move direct comma out of RI. So here this is also, we have previously seen that where whenever there is an at symbol comes, after that register should come. So here it is having an indirect RAM to direct byte. So this will be acting as a source and this will be acting as a destination. So what happens? Whatever value stored in R2 will be considered as a memory location. So 65 will be considered as a memory location. So data from the memory location pointed by R2 will be loaded to 65 memory location. So what happens here? Suppose R2 is having 55. Okay. So this 55 will be acting as a memory location for the data. So 55 equal to 23. Suppose this is what happens here. Okay. So this data will be processed. Where it will be processed? It will be processed to the memory location 65. Okay. So 65 will be the memory location to store the data. 55 is the memory location from where we will take the data. Okay. So suppose this is what happens after executing this instruction. R2 equal to 55. This 55 is having 23. This 23 will be moved to the 65 memory location. Next is move out of RI comma A. So this is nothing but source is accumulator and destination is the memory location pointed by the register. Okay. So example, move out of R2 comma A. So what happens here? So value in R2 will be considered as a memory address as previously shown that. So data from the A register will be moved to the memory location pointed by R2 register. Simple example, same I am saying 55 equal R2 equal to 55 and then A will be having right now 23. Okay. So this data will be processed. Whatever value in A register will be processed. Where it will be processed? So it will be stored to the 55 memory location. From where we know that this is a 55 memory location? From the R2. Okay. So R2 will be 55. This will be acting as a memory location for the data. So data from A register will be moved to the corresponding memory location pointed by R2. Okay. So next same move out of RI comma direct. Okay. So this is also same as previous one. Here previously we have processed with A register. Here we are going to process with the data from the memory location 65. Okay, same R2 will be acting as a address of the memory location. Okay, so 55 is the address of the memory location and then 65 is the memory location from where we are going to process. This is direct, this is indirect. Okay, so data from this memory location will be transferred to the memory location pointed by R2. Okay, pointed by R2 is important. Okay, so this is what happens after executing the instruction. Suppose R2 is 55, 65 is 23. So whatever data in this 23 will be moved to the memory location 55, not to the R2. Okay, R2 is just holding the value which is the memory location for the data. Okay, so don't get confused in this. So next data transfer at of RI comma hash data. So hash means it's immediate processing. Okay. So whatever this 23 will be loaded to the date loaded to the memory address pointed by R2. Okay, that is what happens. So value in R2 will be considered as the memory address of the data. So data will be stored to the memory address pointed by the R2. Suppose R2 is 55 and 23 is our immediate data. So 55 will be having initially 00. After executing, what will happen? 55 will be having 23 because this direct data will be going to this memory location. So this is what happens in this instruction. Next instruction is move dptr comma hash of data. This is 16-bit register. So dptr is, for example, dptr equal to hash of 4100. Why we are giving 4100? dptr is a 16-bit register. So we are loading with dptr equal to 4100. So how this will be processed? So in 8051, dptr will be considered as a two different 8-bit registers. One is DPH, another one is DPL. That means data pointer higher byte, data pointer lower byte. So this is what it will be considered. Suppose initially DPTR is having 000. So DPH will be having 00, DPL will be 00. After executing, what will happen? DPTR, after executing this instruction, DPTR becomes 4100. So that means it will be divided into two different registers. One is DPH higher byte, 41 is the higher byte, and then lower byte is 00. So this lower byte will be going into DPL and 41 will be going into DPH. That means higher byte. So this is what happens with DPTR. Okay.